Hello everyone, in this video I'm going to show you how to install Raylib using Android Studio. Well, not exactly install, just use the Raylib library in Android Studio. There's a way to use the Android library the Raylib library in Android, but it's a little bit cumbersome. Cumbersome in a case-by-case basis. It depends on your application and your preferences, but it's quite cumbersome and it has some quirks. It hasn't been updated in a while, I think. Let's see. Let's go to the GitHub page, and if you scroll down here, you can have instructions to install for Android in your operating system that you're using, Linux, in Mac or Windows. And I think that is a little bit outdated, sorry. In my case, I'm using Linux, particularly Fedora 38, I think, sorry. And it had some problems in the moment of installation. I follow the whole instructions. Actually, the tutorial is kind of based in part of in this guide and others that I encounter. One other than that help, it was somebody trying to install, or not someone trying to install, someone installed another graphics library, this time in Rust in Android. I get a lot of information and inspiration to make this video. I'm going to try to find those videos and the Medium links and post it in the description of the video, so you can support this person and share his video. But anyways, I digress a little bit. It's a little bit outdated. Everything almost here works, except the part of in this, the DX is no longer used by Android. It's a tool called D8, and it changed a lot in the way that it takes its arguments. Also, the jar signer, I think it didn't work. I needed to use the actually APK signer. I will, if you want, I will make a video on how to install it this way. This way, it's interesting because it basically frees you up from Android Studio. Android Studio can be a little bit cumbersome, mainly because it's a little quite resource intensive. So that's one. But Android Studio provides a certain level of comfort if you are, it's an IDE, so obviously has a lot of things included. It's actually IntelliJ based, so it has a lot of tools that IntelliJ offers almost for free. But in this video, my main goal is to teach you how to use Raylib inside Android Studio. To be honest, Android Studio provides a little bit more comfort in this case. It has these idiosyncrasies, obviously. So we have to be aware of that. I'm going to explain those kind of particular things that are very weird, would make it your project, on making your project with Android Studio. Nonetheless, I find it very very comfy, to be honest, and very usable in that manner. So let's do this. First, you are going to open your Android Studio from your particular operating system. As I mentioned earlier, I'm using Fedora, which is Linux. Well, GNU Linux, GNU plus Linux. So to appease the crowd. So in this case, I'm going to just concentrate myself into Linux. I haven't used Windows for 12 years, so I'm really will know how to help you in case you have trouble with Windows. I guess you shouldn't, because we aren't using anything Linux in anything very weird. The only thing that we'll maybe be doing is calling Git from the command line. If you don't know Git, you should. It's a very good application, a good program. It's actually almost mandatory at this point to know Git. So do yourself a favor and learn Git. The amount of Git we are going to use in this video is almost nil. We just need the library of Raylib. We can actually download the Raylib library directly from the GitHub over here. If you want, you just need to do a renaming before proceeding. So let's get this started. First of all, we are going to need a new project. You go to new project, and we are going to choose native C++. This project gives us important tools, which is the NDK and the SDK. Well, sorry, mainly the NDK, the Native Development Kit, which is the one that we are going to use to compile our C code or C++ code in case you're going to use C++ to program your Raylib application. I'm going to use C because I'm more familiar with C, to be honest. Well, actually, I'm a web developer, so I stray further from C for a lot of years. So this is my comeback. Anyways, we're going to create a project over here. You give it a name. It's going to be a Raylib tutorial. You choose the directory where you are going to store. I'm going to use Java because I find it a little bit easier to work more than Kotlin. Kotlin, I haven't got any much experience with it, but it has a lot of, not a lot, sorry, it has some things that make developing your NDK project a little bit difficult. Mainly the way it calls the objects. I don't know how to explain it right away because I'm not so knowledgeable about Kotlin, but yeah, I got some problems with it, trying to make it work. It worked, but it was kind of not difficult, but it was a little bit cumbersome. If somebody in the audience knows more Kotlin than me, obviously, you know more Kotlin, happy to hear your thoughts about it. Next, we choose your language. I choose Java, mainly for familiarity also. I'm having flashback from college. Sorry. Now we are going to choose our NDK, or API. I'm going to choose Android 19 KitKat because I'm developing an application for this supercomputer over here, this Tamagotchi over here. It actually worked. Raylib compiled and it runs pretty well in this supercomputer over here. So I don't know if you can watch the specs of this device. It practically runs labs to an iPhone. It's like more powerful than an iPhone, as you can see. So jokes aside, I have a phone like this. It's like 10 years old. So I'm in toying with it. So that's why I'm going to target KitKat for this moment. You can target whatever you want in your minimum SDK. We're going to leave this as is. Going to see next. Toolchain, you can leave the default. We finish our project. Well, finish creating our project. We are only starting our project, sorry about that. So another thing to mention about the NDK and the native activity, that non-native activity. I'm running ahead of you. Just a moment. Another thing to mention of this type of project that we choose is that we don't have to deal with the GNI. If you choose another kind of project or an object type of project, you will have to deal with the GNI. So this frees you from that hassle. You have to create a folder, and it's a lot of hassle, to be honest, in the GNI project. And I think it was the way before of the native C++ activity. So we just wait for Android Studio to do its thing. There's some things that I like to preface this project. As I mentioned before, it has some idiosyncrasies. Number one, you're going to have a lot of problem with this folder, the rest folder. Here, all your resources that your app uses, for example, images, that logos, for example, drawables, everything that your application uses internally, your internal resources, so to speak, you're gonna have a little bit of problem. I actually solved this problem. A little bit weird the way I solve it, but it's doable. Well, that's one. You have your CPP project. Here is where your application is going to live. Well, your Raylib. Your Raylib library and whatever you do in C is going to live here. Don't worry if you are going to use C. You don't have to worry, to be honest. Android Studio is clever, and if you use C, it knows that you're using C and picks the correct compiler. Kind of. We need to tell it just a little bit of configuration that we just need to do, but it's not very difficult. Well, we are here now. So first thing first, we are going to go to Android project over here. This is the view that to see all your files in their respective directories. And the first thing first, we are going to announce to Gradle, which is the build system of Android. This is the one that it's going to automate a lot of things. We are going to tell it that we are going to build this with C. we're going to copy this part of code over here, because for some reason, if you try to do what I'm going to do right now, Gradle complaints. So over here we're telling Gradle to include a C flag, which is the standard of C. If you have programming in C, you know that you have to specify a standard of the C programming language. There are mainly 3, if I recall correctly. Well, 2 are the most used. I think C99 is staple. And the other one is C11, which is well, obviously 99 is for the year 1999. Then it comes C11, which came out in 2012, I think. And now we have C17, which is the latest. I think there is going to be the next year C23. I don't recall correctly. I'm not exactly a C programmer, so I'm not in the know in this kind of things. But we need to specify here the C flag, or it's not going to compile. I'm going to print C17. It doesn't affect much. And it gives you, I think, UTF support. So you can put emojis if you like. I don't know why would you put emojis in your code, but this is a free country. Well, at least my country is kind of free, so put emojis if you will. So, okay, first step is done. Now, second step, we need to change the activity. This guy over here is going to create an activity, it's going to launch as a normal application. So we don't want that. We want to use Raylib to do all the drawing and the painting and the graphics stuff. So we're going to have to change this to a native activity. Easy peasy. And now that we are here, we're going to change something quickly over here. This part over here, I think I need to make this bigger. Yeah, so you can all see. So if you didn't catch that, we're going to do it again. This is the code as was a second ago. So we change this to a native activity. This is going to allow us to basically, Android is going to surrender the control of the graphics. It's a way of saying it. And we're going to change this to main. Okay, and we can erase this. Oh, I did something very weird. What the hell? Oh, I have the caps lock. Sorry about that. And we're going to delete this for the moment. We are not going to use it. Never ever. This one over also. And done. Now, you go over here and you search for your Android manifest. Now, the manifest kind of stays the same. Well, we just need to do some quick things. First of all, we're going to change the style because we don't need the Android theme. We are not using Android to render the graphical user interface. We're going to use Raylib, sorry. So we need to indicate that. We tell it Android and Tile theme no title bar full screen. I think the name is self-explanatory. It's going to give us a full screen and no title bar, the little title bar that shows in almost all your applications. And over here, we're going to tell it, I don't know how to, screen orientation, landscape. So the application stays in landscape mode. Nothing fancy over here. And yeah, everything is almost the same over here. And that's it for Android for the moment. So we are going to sync it just so Gradle knows all the things that we change. Okay, I think it finished. Gradle, okay, manifest, main activity, all done. Now let's get to the nitty-gritty. We're going to open the terminal. Windows and Mac users, I think they have it, but for you Windows user, I don't know if you have terminal over here, and if you have it, that's good. I think they have it. I don't know if it's the normal CMD, the batch console, or is the one provided by Ming W. I think it's the compiler. Anyways, now that you're here, you're going to navigate to your, let me do this a little bit bigger. You're going to navigate to your source folder. Main, DBP. Obviously, you can do this in your file explorer. In this case, I'm going to do it this way because I'm going to use Git. So we go to the Raylib page, GitHub. We copy the URL. As I mentioned before, I think, if I don't mention it, I'm going to mention it now. You can download the zip and unzip it in the correct directory that I'm going to use now. So as I say it, the Git this instance of using Git is the only one I'm going to use in this tutorial for the moment. So, and we git clone it here. No, sorry, I will need to do something first. I mean, I could leave it. What the hell is happening with this? Sorry about that. Sorry for the abrupt stopping. I just needed to do this. You can do it like I did it like a few seconds ago. This is just so Git doesn't download all the project. We just need the last changes, the more recent state of the library. So deep one just tells Git just download the first. I think it's the head or the first. I think it's the head, just the head of the project. Because if you do git clone without depth, it downloads all the history, and we don't need that for the moment because we are just developing a simple application over here. So, and it's obviously much faster to download. So done. If we check out, we have our Raylib over here, and it should be also over here. Now, welcome to the nitty-gritty. We are going to modify now our CMake. First, we need to change the name of this thing, because we are doing a C application for the moment. We rename it. It's going to refactor it and change it in, guess where, over here. Now everything is fine and dandy over here. You can change your name over here also. Actually, you need to change the name over here to main, because down here, sorry, this is where the library gets compiled. And if you see over here, see project name, this is the name of our project, and this is going to be the name of the library also. Well, actually, this is going to give the library its name, so Java can access it. Don't put other names besides main. Raylib is not going to work if you put here like my library or something like that, and also change it here. Is not going to work. I don't know the specifics, but it doesn't work. It actually needs the library needs to be called main over here. So with that out of the way, now we do one of the most difficult parts, and I say difficult because it's not exactly difficult, but it was kind of a pain in the so first of all, we need to, well, I need to bring something first. Let me copy it because I'm lazy. So we need to have, this is going to be very easy. You need to add a subdirectory, and that's it. If you do it like this, it's kind of going to compile, except it's going to compile wrong. But this is all you need to include your application. Sorry, to include Raylib in your application, at least in Android Studio. But there's a catch. You need to tell Raylib how it's going to be compiled. And I'm going to just give you the source directly, like this. We paste it, and whatever, I don't know. My editor just died. That's one of the problems also with Android Studio. It kind of goes around. So let me introduce you to these things. These sets over here are going to set the compiling variables, so to speak. This one is telling Raylib to not build the examples. There are examples inside the code of Raylib, so you can like test the library. But we are going to tell you that no, don't build the examples. Over here, this is a kind of a hack that I have to do to take the Android platform. So if you go to the website of the GitHub, you can, I'm going to do to the Linux guide how to compile it. You need to pass it some parameters over here. So Raylib knows what platform to target and what kind of library is going to build. So this is what that we are doing over here. As I tell you, this is a little bit of a hack because I needed the Android version, the APK number, not the, because these things just tells you the whole shebang. It actually tells you, if you are, for example, using Android 19, in this case, it's going to tell you Android 19, but I just need the 19. Well, we just need the 19. So with this regex match, we extract the 19 out of the string. Then we have the Android API version. This is the flag that we are going to set. So Raylib knows that I'm going to build for the Android version 19. In CMake match 1, this is the result of the capture group over here. We also specify to Raylib, we tell Raylib, hey Raylib, I'm going to use this architecture. The architectures of Android are ARM v7, ARM 64, and x86, I think. So this is for to target almost every device that can run Android. Every device that can run Android. Obviously, we tell it we're going to build for Android. And these cache strings, please don't forget this. I lost, and I'm not kidding, like probably 10, 11 hours. I think I'm exaggerating a little bit, but I lost a lot of time. Because for some reason, if you don't put this, Raylib ignores them. If somebody is more knowledgeable, somebody knows more about CMake and its shenanigans, please tell me, because I need I have to do this. I think this what it does is like it doesn't cache because CMake and make can like cache things, so they remember. So you don't have to. They don't have to calculate the same parameters again and again. So with this, you force them to recalculate this. Sorry if I'm not explaining correctly. As I say, I basically know just the bare minimum of C at this point. But anyways, we are like basically ready to compile this. Well, almost. We need something first. Obviously, over here we need to. With this, we add the subdirectory. We are telling CMake, hey, I need to add this directory over here. So please compile whatever there is over here with this. And we need to obviously link the library. So our project knows, or our program that we are going to do now knows that it can use Raylib. So we are compiling it with it. The other flags are already set in the CMake of Raylib, so you don't have to preoccupy yourself about this, unless you need to change some things. You can obviously change in your CMake. But anyways, the last thing we need to do over here is not the last thing. Sorry, I almost forgot. I almost forget something. We link it. We link our Raylib. Done. And this one also took me a lifetime to almost yeah, it took me a lot of my life. This, don't forget this, please. This is going to add another flag to the compilation process. In this case, if I recall correctly, this tells the compiler that to ignore this symbol in the compilation step process. My knowledge is shaky on this, and this is a very familiar thing. This is going to tell Android to, well, I know not exactly to tell Android, but if you don't put this, your Raylib application is not going to work. Because I think I need to ignore this part. not exactly the uncreate. I think it overrides it. I don't have the information like at first hand, but if you don't put this, it's not going to work. Anyways, well, we sync our subdirectory now. You can see the build process. It's already built. And now to the nitty-gritty, that is our C program. So first of all, we can like get rid of this. We include our Raylib, and we do yes, no in main void. Now, why void and not the usual char args and everything is because this main is not your typical C main. It's a main that you have to implement. In the case of Raylib, this is the main leaf. I'm sorry, the main of Raylib. This is your entry point of your application. Actually, Raylib manages a lot of things for you in this case. And well, time to build ourselves a little bit of hello world. Hello world, sorry. So I need to explain some things first. So in many examples, you're going to see this. Sorry. I'm going to create a simple window application over here. Let me target another. Yeah. Well, let me see. Sorry for the. I just need to. Okay. So sorry. With the classic example is this. Get screen width. Once int. Get. Sorry. Height. Get screen height. Set config flags. I just try to put the full screen mode. I think it doesn't do anything in Android. I don't recall correctly. And we initialize our window with our width, our height. A title screen. Sorry, a screen title. And we need to set the target FPS. I'm going to target 30 because the potato I'm going to run this is not going to support much of it. And sorry, it's a while. Damn it. I don't know how to program today. Not Windows should close. This is so the application is running, and this is close window. In case the application of the window closes. And let's draw a text. Hello world. And the position is going to be, I don't know, let's see, 50, and font size, what about 30? It's big. And black. Oh, I forgot something first. Sorry about that. We need to tell Raylib to draw things. So begin drawing. I think these are macros or functions. I don't recall correctly. And drawing, if we don't put this, the Raylib is not going to know that it has to do its job. So I think we need also, I'm sorry about that. We need to clear the screen, because if we don't clear the screen, it's going to draw in top of the previously draw thing, and it's going to be something a little bit coarse if you forget this. Clear background, white. just because the only two colors I know. And this should work. I'm going to include something first that I need to show you, so you are aware of some things. So I'm going to show you something first. This is like an Android. It's like a printf. What I'm going to do, but it's a printf into the logcat of Android Studio, so we can see what's going on. It's like a printf, but you can see it in your Android Studio. Android log debug. The tag is going to be Raylib, just because. And with okay, we're going to print the width and height of the screen because I want to show you something. This also took me a lifetime to manage, and it's very important if you want your application to have the correct dimensions, because Raylib does something very different in Android. And the fix, it's very simple, but I need you to be aware of what I'm doing, in case you see other code in mostly in the examples, so you can adapt your code of the examples. So I think this is it. So we can, yeah, I think we can. Let me see if I didn't screw anything over here. No, everything is okay. So we should start building this. I'm going to launch this in an emulator so we can see the process. Let's go. Now it's building. Come on. It's debugging. Sorry, it's compiling. Sorry, not debugging. It's compiling the debug version of our app. So I think here also shows the steps of the CMake compilation. No, I'm sure that here the steps of the CMake compilation show, like over there. It's debugging to x64. This is just the usual warnings that you get with any C application that you build, but it's working. It's actually doing it. So we just wait a little bit. And I think it's about to launch it. Sorry, I need to show the emulator first. It's working over here. I'm going to off them. I have butterfingers today. Well, I'm kind of drunk, so sorry about that. It's going to load. Anytime now. Anytime now. You can. Oh, it's starting now. I mean, it's an emulated device, so be patient with it. For the meantime, I'm going to show you the other thing that I wanted to show you, which is the logcat. Well, it actually installed. So we go to logcat. I think I'm going to show you the application over here. I don't know if it froze or it's still going. It's still going. Whoops. We have ourselves a hello world. Obviously, we need to tilt this. Come on, tilt. Beautiful. And ta-da! You have your hello world. Now, this is kind of a lie. And with a lie, I mean the screen dimensions. The screen dimensions are actually screwed. And we're going to watch it now. We go to logcat. And we wait for it to load. Beautiful. Now we search for this string. I don't know why it's so slow today. I think it's because I'm using OBS. Anyways, it should have worked. Don't know why. Oh my god. Come on, come on. I think it didn't work. Let me restart the logcat. I'm going to start the application just now. We'll restart the application. I don't know why it's not applying the filter. Clean the logcat for the moment. And it's now restarting. Raylib. Come on. Oh, here. Look at this. I don't know if I can make it bigger. Yeah, I can make it bigger. So this is very, god damn it. This is very important. You see? This phone is like 2000 pixels for 1080 pixels or something like that. If you can see, it's a very big screen. But Raylib actually didn't pick the information, and it's telling itself that the width and the height of the screen of the device is 0 pixels. Actually, Raylib gives you a warning over here, I think. Where it is. Over here. Look at this. It kind of picks the right off. It's here. At first time, it kind of doesn't pick the the right screen size. And it just set it to 0, as you can see over here. So just puts it like 0 and does whatever it does. I mean, it's working. But if you want to position something respect of the windows, for example, you want to set it something in the middle of the window, well, you have to divide the position, divide it with the screen width, for example. But you are going to divide by 0, so be careful with that. So this is very important. And the solution is very simple. Very, very, very simple. So we already know that Raylib didn't pick the correct size, but fret not, we have the solution. The solution is to move it over here. Set it to 0. And after that, we just set it with the correct things. And this is going to work. Let me show you over here. Clean this. I don't know why this not picking the Gundam filter. Anyways, well, no, we just wait until the launch, and I think it did it. Yeah, hello world. You see? Perfect. Now we go to the logcat. Now it picks the right screen dimensions. Perfect. So this is almost it. But I actually want you to teach you some other things that may be useful. One of them, I think I mentioned it at the beginning. It's the fact that the rest folder is kind of a pain in, it's a pain in the ass to work with Raylib. So Raylib can access your files in Android via the asset manager, which is a struct or an object in case of CPP that can access the assets of your application. The assets are the things in this folder. But for some reason, it has problems. It doesn't detect it right away. And actually, when that fails, I don't know why, but it fails, kind of fails. It uses the internal application directory. I know it sounds a little bit confusing, but it actually has Android has like two main directories, so to speak. One is the directory of the resources. These resources are are like you can access them with the Android Air object. If I put Air dot I think assets drawable, for example, drawable, and it gives me, for example, this. It gives me the resource over here. You see? And that's cool, obviously, because you have everything at your fingertips. But for example, in case of Raylib, fails with something, fails in that sense. Raylib cannot access, or at least the Android object that Raylib creates. Actually, Raylib connects via Android. Connects to Android via something called the GNI. The GNI is like the translator from Java code to C code and vice versa. So it manages a lot of things for you in this case. But the asset manager, I think, is screwed. I don't know if it's because I'm dumb, probably, but I never make it work. And this object, this struct, actually gets populated by the data directory of your application, not your resource directory, but your data application, where other data is stored of your application. I'm going to show you how to access the data over there. The main problem is that you cannot you need to tell Android, you need to extract the resources of here, the resources that your Raylib application is going to use. You need to extract them over here and pass them. Actually, I'm going to show you what I'm talking about. I'm sorry for the diatribe. It's over here. We can actually, in this cell phone, we can access its data, its internal data. These folders are not accessible to you if you want to check them in your application. Sorry, in your phone. You're not going to be able, unless it's rooted, of course, unless you have root in your phone, you're not going to be able to access them. So in this data directory, the name, I think it says everything. It's the data directory. You can store data over there. And it's over here. Data, actually, is the data that your application produces itself internally. So Raylib only has access to this and can access your external storage as well. The data that you can access with your phone normally. But for some reason, the asset manager in Raylib cannot access this, but can access this. Let me see if the application is installed over here. Android. Come on. Google. Example. For example, aquí. Here, sorry, the Spanish is zipping through. We have our files here. This is the only directory that, for some reason, Raylib sees in Android. So we are going to leverage something. We're going to use Java to copy our things over here. But also, this directory has something that I don't like. Well, it's actually okay. What happens is that if you have two things that have the same name but different extensions, it shits the bed almighty. It complains because obviously it needs unique names, because it's going to be, well, at least Android access this as an object of resources. So if you have two things that have the same name, it just gets confused. So Android Studio says, nope, I'm not going to build anything. Please change the name or whatever. And also has problem with the names. It doesn't allow you to have uppercase name, lowercase, or with weird characters. So we're going to do a little bit of trolling. We're going to actually troll Android. And what we're going to do is we're going to navigate to our project. I actually have something already open here. We're going to navigate to our project. Really tutorial, yes. To the app, to the source folder, yes. I'm sorry, well, we are going to, let's navigate. Main and our rest folder. Okay, we are here. Perfect. Just wait a minute. We're going to create a raw directory. A raw directory basically, well, it's a raw, uh, a raw resource. Sorry, it's a raw resource directory. So we go to res new Android resource directory, and here it tells you the kind of resource directory that can create. We're going to go to raw. We can leave it as is, like raw. We're going to do OK. And over here, this is where we do the trolling. We're going to spice up our application. For the moment, it looks like this, but let's put an image and change the fonts. I'm going to use fonts that I already prepared. This image, by the way, it's in the examples if you want it. And this this font, you can use even the fonts that came with that come with examples of Raylib. But I use this because I wanted to do something spicy first. I'm going to give you the link of this. This is a GitHub repo also, so you leave them a star, please. We're going over here. Now here comes the trolling. We're going to zip this. We're going to create a zip over here. I don't know how you do it in Windows. I think the same way I'm doing it here. That's it. You have your resources over here. Oh, sorry. You have resources over here. We delete this. We don't need it. We changed its name to resources. That's it. And we now go to over here and just open some code. And let me open my code. Just a minute, please. This function over here is going to unzip that that directory, the raw directory. Is going to unzip it in our files directory. There is a catch. Obviously, it's going to do it every time we open our application. So you can put an if or a condition here, but for the moment, for practical purposes, in this moment, we are going to do it like this. So we unzip from raw resource, raw, and the destination path is going to be get dir path. It's complaining about something. What do I get files there? Sorry. Is actually here is raw resources because it's the name of the zip. Sorry about that. And over here, sorry, God damn it, I don't know how to use a keyboard anymore. God damn it. Oh, god damn it. get file 0, get path, perfectly. This is going to zip our resources zip into the files directory, our data directory, and we should be fine and dandy over that. So if we, where is our device? Well, we only need the device explorer. Just look at this. If we run again our application, oh, as always, I haven't imported anything. That's what happens when you just copy code and don't read it. So we need to import all the classes. Well, that's the beauty of Android Studio. Don't rely on this kind of tools, please. I'm doing it because I'm lazy. So I think everything is okay. Thank God for auto completion and LSPs and very nice thing like those. So we should be fine and dandy now. God damn it. Oh, obviously. We run it again. Nice. Now we actually go to our device manager and we click here in synchronize and boom. Now to the nitty-gritty. I'm going to do something funny over here. So first of all, sorry about that. Another CMake lists. So what we're going to do is going to print, we're going to use a font. So we can get rid of this. So I'm actually copying and pasting code that I already make for this. So string. This is just a string, a very long string with delimited with this pipe. It has these weird phrases are called panagrams. They're used to test typographies because they have all the letters of the alphabet in their respective language. This is English. This is obviously this is Spanish, and this one is Korean, Hangul. So well, actually it's Hangul. Okay. So this is going to be a very small application. We are just going to print this in our application, but I want to use a font. So as always, I just copy paste previously working code. What am I going to do? And it's the magic of having been doing this like for almost a week. Anyways, so I'm going to explain the code, obviously. Well, most of the code, because some code I just copy and pasted from the examples. So the code is not so difficult. So first of all, we have our string. Why I'm doing this instead of an array is because I need I need the font to be aware of all the characters that it's going to print. It's something weird because you have, very important, there. This is your friend. Your new friend is the Raylib cheat sheet. So it has all the functions, and it's, trust me, they are very straightforward to use. So you have all the functions that Raylib gives you. So if we go to text, these shaders, sorry about that. Textures, no, text. If you use this and you try to print an Asian looking, sorry about that, with Asian characters or some characters, for example, in Espanol, that in Spanish that has accents and these weird things, and your ñes and everything like that, or your Hangul and all of these under characters, it's not going to work if you just import the font like they are doing here. Like you just pass the file name and everything is fine and dandy. It's not going to work. You need to load it and specify the glyph count. The glyphs are the letters, so to speak. And you need to tell it what glyphs to print. I have this crutch of saying weird, but it's, to me, is weird. Like, but I'm not. I'm not knowledgeable of C or Raylib too much. But well, over here now I have an array of strings, but delimited, obviously. Word mention it. Raylib has its own like utility functions. You should check it in the cheat sheet. One of them is this text split. It allows you to split a string with a delimiter, and it gives you how many strings. You pass a pointer to the variable that is going to hold the number of strings that is going to it encounter with the delimiter. And this thing over here, load code points, it loads, if I understand it, it loads the glyphs in this, every letter that you have over here, or every character, it loads it as it's an encoding. I don't remember the exact details, but it has to know every character that you're using. So it actually converts your string into an int array of those characters converted into a number, and 32 I think is because of UTF-8. I think it's doing because of that. This one over here removes the duplicates. If you don't do this function, it doesn't work. It prints every character. I don't remember how. Well, I don't know the exact details, but this function is declared at the end. It removes the duplicates. Of the code points, and you need it so it works. And now you unload the code points and you pass the not duplicated code points to load font text, and load font text is going to do the heavy lifting of loading the font. And now to draw in that font, we need a special function, x. we pass the font, foundation. We pass a vector in this case to draw the text on the screen. Let's see, 40 by 40. The font size, let's do 1.0. Let's leave the base, foundation base size. The spacing between each letter, I don't know, 1 pixel. The color, let's do black because I only know. Oh, sorry, we need to, obviously, the string, sorry. These are the strings that we splitted, bank. And we're going to do this 3 times. Sorry, no reply 1. Replace with 2. We replace with, what about, let's do 30 pixels each. I don't want to leave them all coupled together. No, I think I'm wrong. These ones stay the same because I want them in the same column. So this is the X coordinate. So actually I need to put them down. So they are one next to each other, I think, I hope. Oh no, this is very complex. We save this. Now, sorry, before I forget. Be careful with the paths that you are, how you write your path, sorry. Because this is the standard for Linux to tell whatever program to search for the file in the same directory. So as you recall, this guy is going to look for things here in files. Every function that deals with files in Raylib is going to look over here. So this tells Raylib, or more specifically the open function in fopen function in Linux, in Android, sorry, to search in the directory in this particular location right here. And this is important for you to put this because I think there is a little bug in Raylib that if you put this, even when it means the same as this, it's not going to work. So please, if you are operating over here, if you are in the root, I think that's the word actually. In the root of the directory, you put this. And if your fonts and in, for example, fonts, you put this. Fonts, pretar, and here you have to have a directory that says fonts. So we leave it like this because I don't have a directory that has fonts. So everything is in my root of this directory. Not in the root directory. Be careful with that. It's in the root of the directory. So perfect. Let's see. It's complaining about something. Errors. Oh, god damn it. You are absolutely correct. Thank God for linters. Yes. Call to undefined function. Let's see. have another undefined function. Memcopy, of course, memcopy. Yeah, we need to import include header string, I think, and we need to include obviously standard leaf. So I think we are ready to move. Let's hope for the best and see what's cooking. And voila. Get this a little bit better. So we loaded our font and we wrote our text. And now let's do another thing, just because, you know, the font is loaded. It actually respects accents and the characters. Well, in this case, the font that I'm using, I think it's Korean specific. I'm gonna link. I'm going to leave links on everything. And now, just for the sake of it, let's draw an image. Well, we are going to draw an image. That's why I put a parrot image in over there. So we go to image, div equals load image. Remember this one over here, parrots.png. Now we load a texture to dim equals load texture from image. We load our image. Obviously, we have to do guard clauses to see the image loaded. So be mindful of that also. If you are actually coding your program to be a little bit more than this toy of a program, you actually don't forget to include your ifs, else, and everything. You need to check even under your bed in C. You need to check if there isn't wrong even under your bed. If you don't leave a pointer dangling in your girlfriend's house or in your boyfriend's house, if you don't leave any memory over there, you need to be aware of everything in C. So that's it only. We load our image because we don't need it, and we draw it. Let me get rid of always. I always push the wrong button. We draw our texture. The position. Let's see. What about I don't know, 90 more than 20, and the color, I think this is in case there is transparency. I don't remember the details. Let's put blue just to see what happens. I don't know what I'm lacking. Can you tell me? 5 arguments and I only bring in 4. Please, magic, tell me. God damn it. I'm drawing text instead of a texture. What texture? God damn it. Sorry about that. I don't know how to speak. Not even in English, not even in Spanish, not even in every goddamn language. Sorry. Okay, so let's do this. Where is our running device? Oh, it actually tints the image like with a blue. And it's also it's not in the wrong. It's in the wrong position. Let's fix that. So we need to get it like a little bit more down for the 180. I think it has. There's a color. Let's put white. But I think there's a way to make it transparent. We need to check. Let's check the cheat sheet. That's why it is set for. So you go to the defines. Oh, I think there's a way over here to make it transparent. It's in the texture. No, you need a tint. Whatever. Something must come up one way or another. Let's do this just quickly. And ta-da! You have your application. So that's it, I think. Obviously, you will need to do as you need. In this case, I think I provided the basics of how to install and compile Raylib in Android. So I hope this helps you in case you are doing an application with Raylib and you want to use also Android Studio Code. Android Studio. I hope it helps, really. If you have anything to add or a comment, please let me know. And it will be nice to see what you are building with this thing. Obviously, more than that, I hope. So, thank you very much. Leave a comment, subscribe, please. And have a nice day, night, or whatever time zone you are now. Bye.